Greetings to you. Welcome to Physics with Ben. Don't forget to like, subscribe, and share this video. Also, click on the notification bell so as to get prompt notification anytime I upload a new content. You may also like to click in the description box below to get all the video series on GCE Physics Alternatives to Particles this year. You may also click in the description box below to get the theory for today's experiment, optics. So, let's go straight to the point. You may see something like this on the day of your exams. A question from optics. How do you go about it? Very simple. Let's go straight to the point. The principal foci, P and Q, of a converging lens were determined. The image of an illuminated object O placed at a distance n from P is obtained on a screen S placed at a distance n from Q as shown in the diagram above. The procedure is repeated for various values of m, and the corresponding values of n were measured and recorded. In figure 2a, POI represents the distance mi between P and the positions of the illuminated object OI. In figure 2b, QOI represents the corresponding distances n between Q and the screen S, where I is equals to 1, 2, 3, 4, 5, and 6. 1. Measure and record the values of M equals to POI and the corresponding values of N equals to QSI. Evaluate N inverse in each case. Tabulate your readings. Plot a graph of N inverse on the vertical axis against M on the horizontal axis. Determine the slope S of the graph. Evaluate K is equal to 1 over root S. State 2 precautions you would take to obtain accurate results if you were performing this experiment in the laboratory. This is figure 2a and figure 2b. BI, state two applications of a converging lens. And then as usual, you may screenshot this when we use BI subsequently in this video. So, first things first. In every video, I always lay much emphasis on the generation of your table of values. So, let's begin. Pick up your pen and write with me. Don't forget I'm making use of WAEC standard graph. So let's generate our table of values. So write observations. Good. The next thing is to come back to this place and check out the parameters that must be included on the composite table. Here we have, they ask us to measure, you see, they ask us to measure OP. OP is a parameter, and this OP is the same thing as your M. They also ask us to measure QO. QO is also a parameter. Look at it here. And this QO, QO, for more clarification, just go straight to this particular line here. This is where you have all the parameters summarized. Here they were stated randomly. But where you see measure and record the values of, that is where you pick out the parameters neatly. So we have M as a parameter, which is equivalent to PO. We have N as a parameter, which is equivalent to SI. And then we also have N inverse as a parameter. In each case, evaluate N inverse. So our table of values is going to have the following. I, don't forget, is the serial number as I've been doing in the other videos. So you write I here, and then you write 1, 2, 3, 4, and 5. Then 6, sorry. It means that you have to run the experiment for 6 times. Then draw a straight line down. The next parameter we have is this, and then N inverse. So we'll write again. So we are done generating our table of values. This is M convert, N convert, and then N inverse. Remember we're having M convert here because it say that 1 cm represents what? 1 cm represents 5 cm. It means that for whatever we get here, we times it by 5 to put it here, and that's our M convert. Here, for whatever we get here, we times it by 5. We put a result here. So let's start the reading process. Don't forget that PO is our M. So this is, the whole of this is for M, this is for M, and this is for N. And the reference is from what? P to O. So in measuring this, we are going to place the 0 cm of the ruler at P. Yes, you can see what I'm doing. So we want to measure the first value here, PO1. From here to here, I got exactly 4 cm. Now record it as 4.00 cm. So I record 4.00. That's it. How about S1, QS, from 0 to this point, or this point to this point? I may put it this way, I'm still correct. So for QS, we have, you can see, this is 11. What do you see? Exactly on the 11th mark. So my N, my first N is what? 11.00. Yes. And so this column, 4 times 5 will give me 20. So I will record here 20.00. That's my M convert, 1 cm to 5 cm. And here I will record 11 times 5, and that will give me 55.00. Here I will say 1 divided by 11. 1 divided by 11. I'll record 0.091. I'll record everything here to 3 dp. And so I want to repeat the whole of this process for the second time again, and then I'll fast forward this video. So let's do for the second time. We measure P to Q, Q2 this time. P to Q2, I got exactly 6 cm. So I will record 6.00 cm. Good. How about my Q to S2? My Q to S2, this is my S2. My Q to S2 is this is 7.1.2.3.4.5. Let's see, this is 7.1.2.3, 7.35. And so I will record here 7.35. Good. So 6 times 5, 6 times 5, that will give me 36. I'll record 36.00 here. So 7.35. Sorry, 6 times 5. Sorry, I said this is 30. It was 6 times 5, not 6 times 6. 6 times 5. So 7.35 times 5. That will give me 36.75. So 1 divided by this value, I put the result here. So 1 divided by 7.35, that will give me 0.136. So I want to repeat the same procedure for the remaining values. Stay tuned. God bless you. And we're done with the table of values. You may screenshot. Thank you. Don't forget, this column is gotten by dividing 1 by everything here. 1 divided by this, we got this. 1 divided by this, we got this. This is gotten by saying this times 5, this times 5, this column, this, everything here times 5. So, the next line of action. We are done with instruction number 1, measure and record, evaluate. We are done with this. We are done with this. We are done with this. Move to the next point. Plot a graph of n inverse on the vertical axis and m on the horizontal axis. So, a graph of this on the vertical axis and this on the x-axis. So let's choose a suitable scale for this graph. So looking at these values, the highest value here is 0.333 recurring decimal. So, and this is going to be on the y-axis. So on the y-axis, we're going to say, which is supposed to be n inverse. We'll say that let 2 cm of the y standard graph equals to 0.05 units. Good. On the x-axis, we're supposed to be the m-axis, the horizontal. The highest value here is 13. We don't take odd numbers, so let's take even numbers. So say that let 2 cm be equals to 2 units. What that means is that each 2 cm we add 2 units, as I've been doing in the other graphs I've been plotting. So To make this work easy, I have decided to copy this table to this small book. So I'll be flipping this book up and down. Now, before we plot our graph, let us predict how the graph will look. Here we are concerned with this value and this value. So you can see that m is increasing down and n inverse is increasing down. So we have an increase trend. And anytime you have an increase trend, just remember that the graph could be one of this or this or this. So any of this graph is gonna be the graph we are going to get. A graph with no intercept, y is equals to mx. A graph with intercept, y is equals to mx plus c. And this one, y is equals to mx plus negative what? C. So any of this graph will be the graph we're going to get. So let's plug in the values. First things first, this time we are going to draw a straight line here, not at the edge. So we draw a vertical line representing the n inverse here. And then we put an arrow up here and write n inverse slash cm inverse. Then we shift the horizontal line a little bit. Let's take it somewhere here. And then we draw this line. Good. You put an arrow indicating the direction of the graph. This is m slash cm. Please don't come and write x here. Write the variables. So for the n, we said 2cm. 2cm simply means from here to this point, 2cm. So we're going to start our graph from the origin, that is 0, 0. So from here to here, let's say 2cm, we set 2cm to be equals to what? 0.05. This is 0.05. Then 0.05 plus 0.05 plus 0.05. That will give you 0.1. So you have 0.1 plus 0.05. You have 0.15. Then you have 0.35. Then on this side, the highest value is 13. So we say that 2cm to 2 units. This is 2, 4, 6, 8. Then we stop at 13. The next thing is to find the value for each small box. Very, very important. In this case, we say 0.05 divided by 10 to find the value for each small box on this line. So the value for each small box on this line is 0.05 divided by 10. That will give us 0.003. So we have 0.003. Sorry, 0.005. 0.005 as a value for each small box here. For this 2 divided by 10. The value for each small box here on the horizontal axis is 0.2. So we're going to divide everything here by what? By 0.005, and everything here by 0.2. That's it. So let's plot our graph. When n inverse was 0.091, m was 4. This is 4. We don't have issues with these whole numbers here. How do we get this one? Very simple. So let's say that 0.091 divided by 0.005. Let's do that quickly. 0.091 divided 0.091 divided by 0.005. That will give us 18.2. We round it down, meaning 18 small boxes will give us this figure, meaning 0.090. So let's count. Let's count. This is 10, 10, then we'll add 8. 1, 2, 3, 4, 5, 6, 7. Count again. This is 1, 2, 3, 4, 5, 6, 7, and 8. So where this line intersect with 4 here, that is the point. Plot it. Good. That point is plotted. The next, but not the least, the next is 0.136 against 6 on the m axis. So we'll say again that 0.136 divided by 0.005, that will give us 27.2. We round it down. 27.2. Let's count. This is 10, this is 20. Then let's count 7. 1, 2, 3, 4, 5, 6, and 7. Good. Where this point, this horizontal line intersect with 6 here, that is the point. In this case, this is the point. We circle it. That point too is plotted. And so we are going to repeat this procedure for the remaining values. Stay tuned. And we are done with plotting the graph. This is the last point. Good. So we have the 6 values 1, 2, 3, 4, 5, 6 plotted. Look at them here. 1, 2, 3, 4, 5, 6 against 1, 2, 3, 4, 5, 6. So the next line of action is to draw our line of best fit. So our line of best fit must touch at least 3 points. I have captured this point. We have captured this point is a black sheep point off. Yes. Yeah. So I've gotten the point. I can draw this line straight now. Good. The graph almost passed through the origin. Very close to what I was predicting. This is the graph we are supposed to get here. Maybe some error due to parallax. But this is the graph I suppose we have passing through the origin. Slightly below this point. So the next line of action is to, you can look at the graph very well, screenshot, good. The next line of action is to draw a big triangle. So we choose a point. These points are not even. So let's make use of this point. Let's make use of this point. Then let's make use of this point. Good. Then you put your dotted lines here. And this is your M1 dotted line here. And this is your M2. This is change in M. Here is your change in N inverse. You trace this particular line here to the edge. And then you trace this one also to the edge. Good. So this is supposed to be your N inverse 2, and this is your N inverse 1. The next line of action is to calculate the slope of the graph. The slope of the graph is calculated as follows. Slope is given as change in N inverse divided by change in M. This is the same thing as N inverse 2 minus N inverse 1 divided by M2 minus M1. So let's read out the values. Good. The value for N2 is gotten by saying 0.005 times the number of small boxes. So let's write 0.005 times. Let's count. This is 10. This is 10, 20, 30, 40, 50, 60, 70. 1, 2, 3, 4, 5, 6 times 76 times 76. And that will give you 0.38. So we'll have 0.38 minus this particular value minus 0.05 minus 0.05 minus 0.05 divided by M2 minus M1. Your M2 is exactly, this is 2, 4, 6, 8, 10, 12, 14, and then 16. This is on 16. Good. So we write 16 16 minus 0.2 times, this is 10 times 11 times 11, that will give you 2.2. 16 minus 2.2. If you do that arithmetic correctly, we have 0.38 minus 0.38 minus 0.05. That will give you 0.33 divided by 16 minus 2.2. That will give you 13.8. If we evaluate that correctly, you're going to have 0.33 divided by 13.8, and that will give you 0.0239. Now, what about the units? Don't forget that it is cm inverse divided by cm, and if you reciprocate this, you're going to have cm inverse dot cm inverse, and that will give you cm. You have the common base cm minus 2, so you have cm minus 2 as the units of your slope. So therefore, the gradient or the slope of this graph, of this beautiful graph, is this. Now let's look at the next line of action. You may screenshot this. So we are done with plotting the graph. We are done with finding the slope. They asked us to evaluate k is equal to 1 over the root of the slope. So we are answering question number VI right now. They say evaluate k is equal to 1 all over the root of the slope. So that means that we're going to say that 1 divided by the root of 0.0239. If you do that correctly, you're going to have the root of the square root of 0.0239. Yep, 0.0239. If you do that correctly, you are going to have 0.1546. So how about the roots of k? Very simple. You know that this is the same thing as 1 divided by the root of 1, the root of 1 divided by cm squared. And this is the same thing as 1 divided by root 1 divided by root what? Divided by root cm squared. This will cancel this, and then at the end, I hope k is equals to 0.1546, back to cm. That's the value for k. So the next question we are supposed to check out, they ask us to state 2 precautions you would take to ensure accurate result if you were to perform this experiment in the laboratory. Now, in lenses, there are precautions that are as follows. Number 1, you are making use of the meter rule. So you say, I would have avoided error due to parallax when taking reading on the meter rule. I would have ensured that the lens was cleaned before running my experiment. Yeah, these are the particular rules that are peculiar to this particular experiment. Sorry, one but important one is this. I would have ensured there is a sharp. I would have ensured sharp image on the screen before taking my readings. Yes, that's the last one. So the next question here is state 2 applications of converging lens. Yeah, the converging lens are used widely in the medical field. They are used to correct eye vision. All the lenses people put on their face are made from the physics behind the converging lens. The telescope, so on and so forth. An object is placed 10 cm from a converging lens when a plane mirror is placed vertically behind the lens. The image formed coincides with the object. This word coincide here, coincide simply means what? Coincide with the object. When an object is placed, when the image coincides with an object, it means that the focal length of the lens is the same as the object 10 cm from the lens. So here the answer is simply the focal length is simply was 10 cm. You may decide to click in the description box below to watch the video on this particular experiment, the theory and the experiment, the physical experiment on this particular alternative particles. To this, we have come to the end of this particular video. Packing my load to leave this place now. Don't forget to subscribe, like, comment, so that I can improve, and also share this video to those that need it. Bye bye, and God bless you.